So I know a few of you came up to me after class looking at the problem set for 5.2. When we covered that the first day, I was only able to cover just the first half of that section. So I just assigned those problems over that first half, and then I assigned the second half of the problems after we covered the second portion of that section. So anyways, I wanted to go ahead and just kind of walk you through some of the problems. I mean, basically what this section, part of what this section is wanting to do is it's wanting to cover the properties of integrals and how they can be applied to different functions. So for number 57, if you look in your homework, I see this inequality. I have this integral. It's greater than 2 and it's less than or equal to 2 square root 2. And if I go through and I look at the properties on page 381, which is what we're being asked to do, I see this property 8, that I think that we can model this problem after. Okay? So if you look at property number 8, basically what it's saying is that if you have a function that falls between two values, lowercase m and uppercase m, and that's for any x value that's greater than or equal to a and less than or equal to b, then the integral of that function from a to b will always fall between that lowercase limit times b minus a. It'll be greater than that and less than that upper limit, uppercase m times b minus a. So let's see if we can get this function here that we're presented with. Let's see if we can get it to look like this. So basically we're going to go ahead and we're just going to start with, if we look at the problem, we know that x has to be between -1 and 1. Okay? That's our starting point. So -1, that's my a value, and 1, that's my b value. Those are the values, that's the range for x. Now I'm going to try to build the function on this. So I'm going to go through and I'm going to square x. So if x is between -1 and 1, then x squared, the smallest x squared can be, is 0. Okay? And the largest x squared can be is 1. Again, I'm trying to build this up to look like my function. If I add 1 to all sides of my inequality there, then I'm going to have 1 is less than or equal to x squared plus 1 is less than or equal to 2. Okay, do you see how I'm getting it? I'm building it up to look more and more like that function. So what do you think the next step is going to be? Well, the next step is going to be, I'm going to go ahead and take the square root of all sides. So the square root of 1 is 1 times the square root of x squared plus 1 less than or equal to the square root of 2. Okay. So now I have my function, the square root of x squared plus 1. And the limits of that function are greater than 1, so that's my lowercase m. And the upper limit is going to be the square root of 2. Sorry, my son just got home from school. So anyways, so now we know that my function itself is going to fall between 1 and the square root of 2. That's my lowercase m and my uppercase m. Given all of these conditions, I can then conclude, conclude using this inequality here, lowercase m is 1 times b minus a. That's going to be less than or equal to the integral from -1 to 1, the square root of x squared plus 1 dx, which is going to be less than or equal to uppercase m, which we just said is the square root of 2, times b minus a. And if I simplify all of that, I get 2 less than or equal to my integral is less than or equal to the square root of 2. Guys, it's just an exercise in proof is what it is.